In this lesson, we want to solve an equation containing a radical expression. Our general strategy will be to isolate the radical sign on one side of the equation. Then we're going to square both sides of the equation, which will have the effect of eliminating the radical sign. The process of squaring will frequently create an extra root or answer. This is called an extraneous solution. This requires that any time we square both sides of an equation, we must check all answers to see if they make our original equation actually true. So let's begin by looking at the square root of w plus 8 equals 6. We want to solve and check all solutions. Now, since the square root is the only thing on the left-hand side of the equation, we can square the left-hand side. Squaring and square root undo each other, so we're left with w plus 8. On the right-hand side, we square this. 6 squared equals 36. And now this is a nice linear equation to solve. If we subtract 8 from both sides of the equation, we wind up with w equals 28. Now that's our answer, but before we write it down as a final solution, we need to check it. So let's go back to the original. Let's replace w with 28. 28 plus 8. Take the square root of that. If I add these together, we get 36. The square root of 36 does in fact equal 6. So yes, this is our solution. What happens if we have the square root and a number all on the left-hand side of the equation? The first step, let's add 3 to both sides of this equation. So we have square root of 2r minus 5 on the left-hand side, and this drops out to 0, and we have a 3 on the right-hand side. Now we can proceed as we did before. Since the radical is by itself, we square the left-hand side and we square the right-hand side. If we square this, notice the square root and the square undo each other, so we get 2r minus 5. 3 squared, 3 times 3 is 9. Let's add 5 to both sides of this equation. So now we have 2r equals 14. So r equals 7 is our answer. But once again, let's go back and double check. If we put a 7 into here, 2 times 7 gives us 14 minus 5. The square root of 14 minus 5. 14 minus 5 is 9. The square root of 9 is 3. 3 minus 3 equals 0. So this is, in fact, a solution for this radical equation. What happens if our equation has both a square root and a letter on the other side? This is going to make things a little bit more complicated. Notice the square root is by itself, so we square the left side, and we're also going to square the right-hand side. When we square the left-hand side, the square and the square root undo each other, so we get b minus 5. When we square a binomial, we don't just square the first and second. We actually, remember, this means we have to take b minus 7 written down twice, so we have to use the FOIL method. So we wind up with b squared minus 7b minus 7b. So altogether we have minus 14b. Negative 7 times negative 7 is positive 49. And now we have b minus 5 equals b squared minus 14 plus 49. This is a quadratic equation. Let's get all the letters to one side. So let's minus b from both sides of the equation. And at the same time, let's add 5. So we have 0 equals b squared. This is a 1, so we have minus 15b plus 54. Now, one of the best ways to solve this is by factoring. Can we find two things multiplied together, two binomials that give us this? We have b and we have b. 54. What numbers multiplied together equal 54? Let's see, we could have 1 times 54, 2 times 27, 6 times 9. Now we're trying to get a combination that gives us 15. Notice if we add or subtract these, 6 and 9 does equal 15. So let's put a 6 here and a 9 here. Since this is negative, we want them the larger ones need to be negative, but since this is positive, they have to be the same. So if we FOIL this, we get here. So we have 0 equals b minus 6 times b minus 9. So either 0 equals b minus 6 or 0 equals b minus 9. If we add 6 to both sides of this equation, so we have b equals 6 is one answer. If we add 9 to both sides of the equation, we have b equals 9. So these are our two answers. However, we better go back and put them into our original equation. If we put 9 into here, 9 minus 5, so as our check we have the square root of 9 minus 5 equals 9 minus 7. 9 minus 5 is 4, the square root of 4, so 2 equals 2. So 9 works. Let's try 6. Put 6 in here, we have the square root of 6 minus 5, which is the square root of 1, which is 1. If we put 6 minus 7, we get negative 1. Uh-oh, this one does not work, so this one we're going to throw away and call it extraneous. Let's try one more like this. Notice the square root radical on the left is not by itself, so we need to begin by subtracting 8 from both sides of the equation. So we have the square root of 3a minus 2 equals 2a minus 8. In order to get rid of the square root, we square both sides. So on the left, the square root and the square undo each other, so we have 3a minus 2. If we square this binomial, notice we take 2a minus 8 times 2a minus 8. So we get 4a squared minus 16a minus 16a, so that's minus 32a plus 64. So, please notice whenever you have a binomial to square, you get 3 terms. Frequently students will forget to do that middle term. You want to be extra careful there. Let's subtract 3a. We want to get all the a's together. Let's add 2. So we wind up with the 0 on the left-hand side equals 4a squared minus 35a plus 66. Let's see the factors of 66. We can multiply 1 times 66, 2 times 33, 6 times 11. 4a squared we can multiply 1 times 4 or 2 times 2. So if we work with this a little while, notice that the number in the middle is an odd number, therefore we can't have all even factors. So we need to have something odd. So let's put a 6 here, and 11 here. Let's try 4a here and 1a here. Since this is positive, both the signs are the same. Since this is negative, the greater one is negative. Let's see what happens. If we FOIL this, 4a times a gives us 4a squared. Outer terms would give us negative 24a. Inner terms would give us negative 11a. That gives us negative 35a. So this is the correct process here. We have factored this trinomial into 2 binomial factors. So either 0 equals 4a minus 11 or 0 equals a minus 6. Let's add 6 to both sides here. So a equals 6 will be one possible answer. If we add 11 to both sides of the equation, so we have 11 equals 4a, divide through by 4, so a equals 11/4. So these are our 2 answers. However, so we have our answer, a equals 11/4, a equals 6. Remember, we need to check each of these. Let's put 6 in for our original equation. Let's put 6 in for a here, 6 here. 3 times 6 is 18. 18 minus 2 is 16. The square root of 16 is 4. 4 plus 8, 2 times 6 is 12. So this one works. A equals 6 is a solution. Let's try 11/4. See if that's going to work. Remember, we must always check if we square both sides. So we have 33 over 4. Let's see, let's multiply this by 4 over 4. So we have minus 8 over 4. 33 minus 8 is 25 over 4. The square root of 25 over 4 is 5/2 plus 8. 2 times this cancels 2, so we're left with 11/2. If we multiply by 2 over 2 here, we wind up with 5/2 plus 16/2. So that gives us 21/2 on the left equal to 11/2 on the right. So this one does not work. This root is in fact extraneous.